Hi friends, this is Ritvik. In this video, I am going to explain about how to draw an automata to a given regular expression. So, for this, first we need to know about what is mean by a regular language. Then after we will move on for how to draw an automata for that. So, a regular language means a language which is recognized by finite automata. It may be a NFA, DFA, or NFA with epsilon naught, etc. Let us see an example. A language a power n b power m with condition n comma m greater than or equals to 1. Here n and m are independent to each other. That means n and m are not dependable on each other. So we can write AB, AABB, ABB and so on. So it is an finite automata. Therefore we can draw an automata for this language like this. Finally we decided that it is an finite automata. Now let us see a theorem, that is, every regular language defined by a regular expression is also defined by finite automata. So to prove this theorem we need to know about induction, where mainly induction is divided into three cases: case 1 union, case 2 concatenation, case 3 clean closure, where union can be represented in three symbols plus, u and slash, where concatenation is represented in only one symbol, that is dot, and finally clean closure can be represented in symbol star. Now let us learn how to draw an automata for each cases in induction. First, let us see union of regular expression. Let us consider R is a regular expression of union operation in between regular expressions A and B. First, draw an automata for expression A separately and B separately like this. Then first create a new starting state. Let us take it as 0. Starting state 0 start, which need to contain new transaction on epsilon to the starting states of both A and B. They are 1 and 3 like this. One is an starting state to A and 3 is an starting state to B. And then take transaction from final state of both regular expressions. This is the final state for A, this is the final state for B, to form a new final state. Consider the final state as 5 with a regular transaction epsilon, with epsilon transaction. Now this diagram becomes an automata for regular expression R. In the same way, let us move on for case 2, concatenation of regular expression. In this also, let us consider R is a regular expression of concatenation expression in between regular expressions A and B. Here also first draw automata for A and B separately. Now let us draw automata for R, where the starting state of regular expression of R becomes the starting state of A. Where 1 will become the starting state for R. Now the accepting state of B becomes the final state of R. Four becomes the final state for R, where these two are the concatenation of regular expressions A and B is done by providing a path from the final state of A to the starting state of B on epsilon transaction. Now this diagram will become the automata for regular expression R. Now let us see the last case, that is closure operation of regular expression. Let us consider A as a regular expression, then R has a regular expression of A star. First draw an automata for A like this. Then to draw a regular expression for R, first create a new start state. Let us take it as 0. And draw a path to the starting state of regular expression A on epsilon transaction like this. And then draw a path from final state of A, that is 2, to the final state of R on epsilon transaction. Take final transaction of R as 3 on epsilon transaction, and then draw a path from final state of A, that is 2, to the starting state of A. 1 is the starting state of A on epsilon transaction, and then draw finally draw a path from starting state of R, that is 0, to the final state of R, that is 3 on epsilon transaction. Till now we have seen the basics of regular expression. They are union, concatenation and closure operations separately. Now our main aim is how to draw an automata for regular expression which contains all three operations. So let us take an example like this. First explore this expression in detail. First take operation concatenation in between symbol 0, 1. Then add star operation for this. Then finally add union operation with symbol 1. So draw an automata for this in stepwise. First take concatenation in between symbols 0, 1. Start. Take A as a starting state and then draw the automata for 0.1. Take D as a final state. Now apply star operation for this expression. Now take E as a starting state where it was added with epsilon transaction to the starting state of 0.1. Take F as a final state. Now from D to E we need to draw a path with epsilon transaction and also draw a path from starting state E to the final state F on epsilon transaction. Now we need to come for the final operation of this expression, that is union. Now the expression will become like this. Now take G as a starting state with epsilon transactions, where in this part the automata will be taken of this one. In this part we need to draw of the automata for 1. Epsilon. Now draw an automata for 1. Take starting state as I and final state as J for automata 1. Now for union operation, take final state as H with epsilon transactions. So now this diagram will become an automata for the given regular expression, which contain 3 operations: union, star and concatenation. So now for the better understanding, we will move on for the next example. Let me take this example. First write this expression in detailed. First write this 0 plus 1 whole star dot 0 plus 1 whole star dot 0 plus 1 whole star. If we see this, we can understand that only the expression 0 plus 1 whole star is repeating 3 times. So first draw an automata for 0 plus 1, then apply star to it, 0 plus 1 whole star, and then add concatenation to the 0 plus 1 whole star 3 times. So let us move on to draw an automata for this expression. In step 1, first draw an automata for 0 plus 1. Only draw an automata for 0 plus 1. Take A as a starting state. And F as a final state. Now add 0 plus 1 whole star for this expression. Now take G as an starting state. G as a starting state. Sorry, I didn't take and start here. Start with epsilon transaction. And take H as a final state, and where we need to draw a path from F to A on epsilon transaction, and also we need to draw a path from G to H. Here we completed an automata for 0 plus 1 whole star. Now we need to draw automata for 0 plus 1 whole star dot 0 plus 1 whole star dot 0 plus 1 whole star. We need to repeat this expression with concatenation. Then the automata will become like this. Finally, the automata for this expression will be seen like this. So thank you friends for watching my video. So I hope all of you understand how to draw an automata for mixed operations.